Ready to find your flow? AFSA's got you covered.
That's right. The hands-on training lab in Richardson, Texas is where you trade PowerPoints for pipe wrenches. Real tools, real systems, and real experience you can actually use.
And if you're ready to test your skills, check out the hands-on NFPA 25 workshops, where you'll inspect, test, and maintain live sprinkler systems and fire pumps. No simulations, no fluff, just pressure, flow, and know-how.
It's the perfect way to get under pressure without cracking under it.
So get fired up and register today at firesprinkler.org. Spots fill faster than a charged branch line.
AFSA, where you don't just learn the code, you live it. Welcome to the K Factor podcast, where we turn up the heat on all things fire protection. Brought to you by the American Fire Sprinkler Association, this podcast sparks conversations about the latest technology, trends, and tools shaping the industry. Join the AFSA tech team as we fan the flames of innovation in fire safety.
Welcome to another episode of the K Factor podcast. Really exciting. We have NFPA Global Solutions, Dyne. We have Grant and Joan in the podcast studio. Thank you all for being here.
Yeah, thanks for having us.
Yeah,
Thank you.
no problem. So NFPA Global Solutions and Dyne's kind of a new thing to the industry, it seems, when you talk to people. Could you tell us a little bit about that and how that came about and what y'all are doing?
Why don't we start with Dyne? So we have been around for a little over 25 years. 1999 is when we got started, and Joan actually founded the company.
Awesome.
Do you want to say a few words about...
Sure. I had some experience working at 3M for several years in their firefighting foam. And I left 3M because I had kids and I was traveling. And I always had this idea 3M would test firefighting foam in-house. But they didn't do it very well. They didn't prioritize it. It was kind of like, oh, there's some samples if we get to them. So in 99, I started Dyne, and the key to Dyne was trying to make it as easy as possible to get the job done. So we provided a test kit with bottles. We developed a database, so the data was always kept, and it went very well. So we did firefighting foam until we started doing sprinklers. What year was
late
that?
2016. So I came in about 2013 is when I came in. And we added sprinklers in 2016. This just came up organically with contractors. We're doing firefighting foam, and they come to us and go, I love this service. We've made it really easy for us. Can you do the same? So as we get into this, we really play in that NFPA 25. That's where we want to be. And we're just a few small sections of that, right? The contractor's got a lot he's got to do in NFPA 25. And there's a few things as they page through it that says, oh, I can't do this. I need a lab to do this. And that's where we try to come in. So we were fulfilling foam. They go, okay, you're doing great at this. I need some help on this. Can you do this? Sure. We look at it. We added it in late 2016, 2017. And then that's quickly taken off. We have a few other small services as you page through there. Antifreeze, if you guys are familiar with that, in sprinkler systems, right? Doesn't say you have to use a lab, but some contractors choose either I don't have the equipment to do this, I don't want the liability. We are able to assist with that as well. So again, as Dyne, been around about 25 years, we really play in that NFPA 25 field for lab. So again, few small sections, but that's where we want to fulfill it. And we want to make it very easy, right? That's what we always say. One of our biggest competitors at Dyne is people that just don't do it, right? Before we hopped on here, we were talking about that, and right? So that's one of our biggest competitors is the people that choose not to do it. And how do I make them do it? I just make it really easy for them, right? So that's what Joan founded this on, is let's make it easy for them. We've rolled that into every service we have. We have these free test kits, these free boxes. In the case of foam, it includes some bottles. In the case of sprinklers, it's got some padding because I need to get the sprinkler to me as it was in the system, right? I can't have it damaged in transit and changed. So every service we offer in 5 days. Again, that's going to help the contractor. Hey, get us the sample. We're going to get you that result quick so you can act upon that. Right.
So dipping your finger in the antifreeze solution, tasting it, and see how sweet it is isn't the right way to do that.
No, you are correct. That is
foam
not.
too,
No,
probably not a good.
No,
Definitely.
foam definitely does.
yeah, that's definitely
Well, especially with all the stuff recently that's come out about foam, probably best not to taste it at all.
Yeah.
Much less be around it too much.
So what did the facility start out? So a lot of questions that we get is like our labs, right? Where do we send these? And Dyne always comes up, of course. What does the lab look like, or what did it look like, and what does it become?
Go ahead.
Well, I would say initially we did rent space right off the get-go, and we had I don't know, about 800 square feet.
Okay.
And I was doing a lot of the testing. I had one technician. We had a office. We do a series of tests on firefighting foam. There's physical property tests, things like viscosity, density, refractive index is a big one as well. Mm-hmm. And then we actually mix the foam at the concentration, and we shoot it through a nozzle against a backboard, as you would see in NFPA 11. There's a diagram of it in there. And measure the expansion, the drain time. If it's a film-forming foam, we make sure it still forms a film or that has a positive spreading coefficient. So we're doing surface tension tests. So it looks like a laboratory, right, a chemistry laboratory. I'll let Grant explain the sprinklers because he's more familiar with that than I am.
Yeah, so the foam side is very much laboratory. Now, it doesn't look like CSI Miami, right? Everyone thinks laboratory now, where it's like pristine big and gloves, all glass. Yeah. But there's bench tops, there's fume hoods, things of that nature. So that is a much more chemical test on the foam side. With sprinkler side, it's a much more mechanical test, right? In the test, we simply put it in an oven. We monitor how long it takes to go off. Sounds very simple. The oven is pretty massive. It's about 8 foot by about 4 feet high, maybe about 2 feet wide. Why it's so massive is we want the nice control both on temperature and airflow, nice laminar flow, keep everything very consistent so we have a very repeatable test, right? And everything we do, and I'm sure in other laboratories, right, we want to make sure that's very repeatable. If I do it, if someone else does it, we get the same result. If I do it 10 times, I'm getting the same result. So in the sprinkler lab, much more mechanical is these ovens, again, these massive devices. It's controlled by, it looks like I always say a carnival kind of control panel is what it looks like on the side, right? It's got all these buttons and knobs, but that is essentially the laboratory for sprinklers.
So it's a tunnel, right?
Yes.
Air past
we call it a plunge tunnel. We plunge the sprinkler in, yep. And that's a common misconception of our sprinkler test is people give us a sprinkler, and let's say like the sprinkler we have in here is 155 degrees Fahrenheit for activation, and they think, oh, you're going to verify that. We do not do that on the periodical basis. Could I do that? Yes, I could, but it would take a very long time to test. I got to start at ambient and very, very slowly ramp that temperature up until it goes off. It's going to take a very long time, which then equals very costly, which again gets back to the standard of this is probably not going to be done. Doesn't make sense. So what the industry has chosen for sprinklers is we're going to test how long it takes to go off. We're going to plunge the sprinkler well above that. In the case of the 155, we're plunging it at 275. And then we monitor, okay, how long is it going to go off at that temperature? We, and the standard, refer to that as sensitivity. How sensitive is it?
Is that the response time index?
Response time index, you got it, exactly. So when I say how long it takes to go off, that's a time. The standard does not tell me, hey, this sprinkler needs to go off in a minute and a half. It does not say that. It says this sprinkler needs to have an RTI less than 350. Why does it do that? Because when I plunge a sprinkler, how long it takes to go off, there's many variables affecting that. Okay, it's how cold was it when I put it in, right? Outside, the ambient temperature. How hot is the oven? How fast is the air flowing by it? All of that can impact the actual time it takes to go off. So the industry's decided, we have this equation where I can standardize that. I can put all these variables in there, and it'll give me this response time index. So no matter if we're testing it at Dyne or at the manufacturer or anywhere else, we can take the variables in our laboratory, and we should all be able to get the same response time index.
So I'm guessing we have some kind of a standard. What does that look like when so I've pulled sprinklers out of my building, right?
Yes.
I've packaged them up, send them to you. Do they sit in a shelf for a certain amount of time to basically hit a specific ambient temperature so that they're all going in with the same conditions, and then what they get attached to from the videos I've seen, it looks like a plate
there's videos online.
A couple tubes going. Can you explain more how that process actually works? What are you actually looking at? Kind of that. Yeah, I send the sprinklers off and they magically go off and I get a report back. But what does that look like as far as the functionality testing goes?
Yes, we can start there. At some point we want to come back to, we should start at, the person taking the sample, how that process goes.
Don't worry, I have questions on that too.
Oh, yeah. So let's start with the test itself, right? It arrives at our laboratory. Hopefully they used our free kit. One, it's just going to save them some money and includes free shipping in the contiguous U.S. Two, it's going to make sure it arrives safely to us. So we do test the sprinkler in any condition other than if it's damaged, right?
Okay.
If a sprinkler has already been activated, we have got these, right? Individuals will take and just ball up the sprinklers, throw it in a box. It's bouncing down in transit, and there go all the glass bulbs. There's nothing I can give you.
Right.
But if it's corroded, loaded, I will still test it and give you results. but other than damage, I can't. So it arrives at our laboratory, hopefully safely in our kit. Our staff will check it in, so they will look at the sprinkler, they will enter all the information. So we do provide that in the report. This is the model, the make, the year, what mechanisms, what kind of release mechanism does it have, what kind of water seal does it have. That's all information we put into our system. It gets into the laboratory. To your point, yes, we have to give it 24 hours, as we say. You really don't need that long to reach ambient in our laboratory, but you are correct. It needs to be at a stable temp, so we can then plunge it into the oven. That you were right on too. You've watched the videos where the sprinkler we can take and we attach it to a test plate. Yeah, you attach it to this test plate. And then you're going to put it into the oven on this test plate. You attach some pressure. So we just use air pressure. The standard actually says to test it at 7 PSI or the minimum listed pressure for that.
Is that the UL standard?
This is NFPA 25 it actually comes from. Okay. So you are correct. In some NFPA documents, it'll just say, hey, we got to test it, but not give guidance. One of the the sprinkler standard is very good about giving you parameters and requirements for this test. So 7 PSI comes right actually from the annex of NFPA 25.
Yeah. So we're going with that minimum end head pressure. But if our minimum end head pressure is higher, say for like a ESFR sprinkler where we're at, say, 50.
Yep.
So we're basically pulling either the minimum end head pressure or whatever the manufacturer's listing requirements are. Okay.
Yep. That's a common question we get all the time. Okay, it failed at 7, Grant, but my system's at 50. Can you do it to 50? Can I do it? I can do it, but it's not going to change the result because NFPA is very clear. We're going to test it at 7. And people will argue again, well, mine's way higher. Let me tell you this, that when it was listed, it was tested at 5. So we've already allowed some room for degradation in there. We've allowed 2. And I think the standard and I think the committee would say is, well, yeah, yours at 50 now. But we can't, we need to have some sort of minimum, and we don't know if the minimum is 7 that it could ever be used at. We should verify that it's used at that absolute minimum.
Right. Well, the other thing I think kind of tying in for some of our designers will probably appreciate this, but I think some of our ITM folks might not, if they don't have a huge background in design, maybe fully grasp the concept of if you're sitting at 50 at the riser, by the time you get through the piping network, you've got friction loss, you've got elevation.
Yep.
You don't know what your end head pressures maybe actually sitting at. You might have 50 at the riser. You might be at 20 at the end head, or maybe we're down closer to that 7.
You got it.
And you're not going to know that information. Even if you're sitting higher at one point, far into your building, you might be lower. And so that's probably also another good reason to, even though you think you're at 50, you might only be at 50 for a short second, right? And then
circle back a little bit. You said physical damage you can't help with, right? And I think that's a big thing.
A bent deflector, it depends on the damage. But if I can't hold pressure when I put the sprinkler in my oven, again, I talked about attaching it to the plate.
Right.
I connect my pressure. If I can't hold pressure, my instrumentation will not work. Because how it works is then I plunge it in the oven. Once the sprinkler activates, that pressure is released, and that's what stops my timer. So that is the one, if it can't hold pressure, if the release mechanism is activated, the water seal has gone, or even if it's just up a little bit where it won't hold pressure, that's the one condition.
Cattywampus, I think they say in Texas.
There you go, perfect. But other than that, we will test just about anything, right? And people, when we first started this, I would contact the customer. They would send us a sprinkler, and why are you sending me this? Clearly fails. This gets back to, the process for taking a sample. They should do that floor level inspection first.
Right.
And anything that fails that, we should replace then. What remains, that's what we're going to test from. So I would call them and, this clearly, I know I'm not looking at it from the floor, but even from the floor, I can see this. This is an issue. Why'd you send me this? And they will say, well, Grant, I know, but the building owner will not do anything without your report.
Right.
So that's why we took the stance, we will still put it through its paces. We will still put it in the oven, get you data. Most often it's not going to go off. But sometimes we understand these contractors, we need this report that says, even the contractor says it, they want this report from us or a laboratory kind of giving that stamp of approval that, this is a problem.
Yeah, they're getting pushback from their owner that says, hey, you're saying that because the inspection criteria for sprinklers, it does give some wiggle room there, right? Because you're looking for loading detrimental to sprinkler operation.
You got it.
Corrosion detrimental to sprinkler operation. Now they've added paint.
Yeah.
Right? That's a big change that came out recently of paint detrimental to sprinkler operation, because it used to be any amount of paint was an instant fail.
Correct.
Which I'm kind of curious to pick your brain on what you're seeing from experience with paint on there. But there's going to be a gray area. I think we could probably all find some sprinklers that are somewhere in that gray area, and we're probably all going to have a differing opinion on, when is it when is it detrimental? Obviously Josh and I with an insurance and our background in insurance are probably going to be a little bit more conservative than, say, somebody who hasn't seen the loss reports that are constantly coming through. So, that's one of the discussions we have with our ITM technicians that come through our training is, okay, at what point are you making that judgment call? But it's probably some of that. So do you have any?
Before we go down that rabbit hole.
Oh, okay. You know where I'm going.
Yeah. That's before we go down that rabbit hole. So it's clearly on the sprinkler side, destructive testing. Mm-hmm. In the sense, like, I send you my sprinkler, even though I love this sprinkler.
Yes.
We're nerds. I'm not getting it back.
No.
And it's not going to definitely
We
work.
get that question from time to time. Can I have it back?
Yeah. No.
It's all in pieces. I don't know what you're going to do with it, but.
Is it the same for foam?
We require just an 8-ounce sample.
Okay.
And we dispose of it ourselves. And of course, that's a lot more difficult nowadays. Yeah. So we have to send it to a hazardous waste incineration. And we have chosen to continue to test AFFF samples. Right. A lot of the manufacturers are no longer doing that. But we invested quite a bit of money to be able to do that and do it properly and keep our employees safe and dispose of it properly.
And are you seeing a lot from the fixed systems, or are you also doing firefighting foam for the CAF systems or the firefighters?
We do it for all of them. We're willing. I would say the majority of ours is, Class B firefighting foam from refineries, hangars, truck loading racks, more of the industrial.
Stuff. Yeah.
And we do quite a bit of high expansion systems too. High expansion doesn't have fluorine in it typically. And those are on a lot of aircraft hangars, and we do that as well. So we have a device in our laboratory that will generate high expansion foam.
Oh, awesome.
And measure the expansion. Yeah. So, you have to come visit.
I do know.
It's really cool.
Nerd out a bit. So, didn't mean to. I just wanted to.
Oh, no, you're good.
All right, go for it.
Okay,
Eric, for those listening, has been a kid in a candy shop with Dyne coming in because he heads up our ITM development program, does a lot of our inspection, testing, and maintenance. And he's been dying.
Very excited. Very excited. And it's a lot of the questions that we'll get in from our students. And I've got an idea. I've got an understanding. I've watched the videos that are out there. I've got a very decent understanding
on TikTok
how it works. I think.
Yeah.
Right. But I'm not the expert on this.
Yeah.
So I've got some stuff that I just want to pick y'all's brains on.
Yeah.
That I think that are questions that other people have.
Sample size.
Why don't we start there? We'll start the beginning at the contractor about to sample. You just stop me if you have a specific question.
Go for it.
So let's start right there. Out there for NFPA 25, where we provide the sprinkler test starts is really that floor level inspection, that annual floor level inspection, right? So all those things you mentioned, the corrosion, loading, now paint, detrimental to performance. We're looking for damage, loss of fluid in the glass bulb. They should go and they should do that floor level inspection, replace anything that clearly fails there. And to get to your question of, detrimental to performance, that's not very clear. I agree. We get that question all the time. We do have some resources on our website. We have taken sprinklers that we think visually look on the edge. Now, again, keep in mind, I'm looking at it right in front of me where the contractor's looking at it from the floor. But we provide that image and we provide here was the result. Try to give you a sense of here's kind of what's on the edge. But I will always recommend what I'm talking about today and what we typically refer to in the standard is really routine testing. You can do non-routine testing at any time. We'll talk about the intervals in a little bit, but if you're out in the field, you're like, I don't know about this one. All in this room, they all look the same. They look like that. Is that going to be okay? Everything I'm talking about the number you got to send in later and when to send it in, you don't have to follow. You can just take one sample, send it to our laboratory. We'll test just one sample, get results back to kind of help you. Is this detrimental? Get me a sample and I can verify, okay, here's what time it went off. And that can help you make the decision as well.
So that's the outside of the kind of the testing that's
described inside Section 5. Yeah.
Right.
Yeah.
So, because they're saying 4 or 1%, whichever is greater. But if I'm just trying to make a judgment call, I can send in one. I don't necessarily hit that. Okay.
Yeah. And that's going to measure response time, not necessarily the other performance characteristics.
Correct. Yes. With with our test here, response time, that's how, again, the periodic purposes. When you have the sprinkler listed, there's a lot of tests, right? And you're going to do corrosion testing on it, water distribution pattern, right? We are going to verify the activation temp. There's a lot that goes into that. We can't ask the building owner periodically to always do it. It's too much. Right. So that's where, okay, let's take a few key benchmarks. Typically in the industry, in anything you're testing, you're going to choose something, oh, this is a good indicator when it first starts to fail. Right. In this case, we've chosen response time. So yeah, you could send to the lab. Corrosion, loading, even paint. The response time is a good benchmark to check because corrosion, that can help seal things up and fuse things together, and it won't go off at all. Loading, typically, so loading, if people are questioning, is just really any foreign material that's on the sprinkler. So I often use my vet. I have a dog at home, and I go to the vet, and I look up, and oh my goodness, there's just a ton of dog hair around it. That sprinkler will probably go off, but it'll be delayed.
Right.
That dog hair or that dust, whatever it is really just going to act as insulation. It's going to delay. The heat will eventually get there, but it's going to take longer, right? I have more thermal mass. I have more stuff to heat up and get through to get that to happen.
What if it goes off too soon?
If it goes off too soon, that's not something currently in the periodic testing purpose. There's no minimum. Okay. At listing, there is, but that is a good question. Yeah, there is no, it just has to be off before RTI, less than 350 for standard,
right,
less than 65 for quick, less than 50 for ESFR.
From a practicality standpoint, is that something that you would think that maybe we should start adding into the standard?
It's something
as far
to
as if
consider.
It's going off quicker?
Yeah,
because I know we're trying to avoid mixing response types, things like that in a space, and I imagine that's the same concern there.
Yes.
But is that something that...
I mean, it's something we can certainly identify. If I have someone who thinks they have standard response, one, we will tell them, like, you do not have standard, you have quick. We can tell that just one, it's etched on the sprinkler. Two, based on the design,
right,
a quick response sprinkler, the release mechanism is a lot thinner, less thermal mass, it'll go off quicker. But yeah, there could be a need at some point. We were talking about industry, you guys from the insurance side before this, and the water damage, right? People do want to know, am I going to have premature activation?
Right.
Especially with solder mechanism, these heating and cooling cycles. So an NFPA 13, which is then pulled into NFPA 25, that they have that maximum sealing temp.
Right.
That's in there because of that issue, right? If I have a sprinkler that goes off at 155, and all of a sudden up there is 140. Okay, it's not at the activation, but it might be enough if you have a solder mechanism to make that solder slightly malleable.
Right.
And then it'll kind of spread out. And then if it cools, it'll reharden, but it'll reharden in a less than ideal state than when it was before all that.
I think they're calling that solder migration. I think is the term they're using
solder
for
creep, solder migration. Yeah, there have been talks.
What do you like that?
Solder creep. It's better than migration.
Yeah. Things like that. So, you asked the question about, do you think we should have a minimum? There could be some arguments made for that, yeah. But typically, we're not seeing a ton of that at the laboratory.
Okay.
The most common failure is it just the water seal does not release.
Right.
The mechanism will break, but the water seal remains. And the number one reason for that is corrosion, either internal or external, right? So sometimes we'll have a pendant sprinkler and it's been leaking just ever so slightly around the water seal. You'll never notice a drop because it evaporates before it falls off there, but it's enough where it'll start to build up corrosion, right? We got water, we got air, we got metal, we got corrosion around the water seal. So that's a good sign when you're doing your flow level inspection. If you see corrosion on a pendant sprinkler and it's just isolated around the water seal, maybe you do have a slight leak there. Or again, we have very cold water, we have hot water outside. That could be a mechanism there where condensation's building up and we have corrosion there as well. Right. Or internal, right? Water supplies. We could have some nasty water supplies here and inside is just corroded, held that water seal in place.
Right. So do you, on both ends, do you collect this data and utilize it to maybe make some adjustments? Because I've noticed like the dry sprinklers have creeped over time. I'm going to start using that term.
You are correct. Not only ourselves, but our other other laboratories in the industries as well. Yeah, that is why you bring up a good point. We'll talk about intervals. Dry sprinklers went from 10 to 15. Now it's at 20. Why is that? Well, originally at 10 because prevalent in the dry sprinkler industry, the designs was O-ring sprinklers. Right. And it's been probably 20, 25 years now since.
Use the swear word?
Yeah, there you go. It's been a long time since O-ring sprinklers have been listed at UL. So we are slowly weeding out of those. And as we get those out of the market, out of the field, the failure rate for dry sprinklers has dropped considerably. So where the committee thought, okay, we can now wait. We trust it to 15. We trust it to 20. I don't think anyone in the committee loves the fact that for sprinklers, there's these intervals all over the place, right? We got 5 years in harsh. We got now it's at 20 for dry, 20 for ESFR, 25 for quick, 50 for your standard. I think they would like, okay, can we just get one number? Ideally, can we get two numbers? And I think that is data driven to your point. Where same thing with Quick went from 20 to 25. It's just, okay, the failure rate is low enough where we can wait there.
Do you expect that for quick response sprinklers? Do you expect that to continue to get pushed back until we hit either 50 years or some interval where we actually start to see? Is it because I'm assuming we're pushing it back because we're just not seeing the failure rate at the 25-year mark? But all things considered, quick response sprinklers are still relatively new to the industry, quote unquote. Right. So I don't know if we have quite the breadth of testing for the longer interval, right? But is it something where we're starting to see these have been around for a little bit now? Are we starting to see that, okay, they were passing pretty much consistently at that 20-year mark. We're slowly bumping it back. Do you expect that to continue to creep back until
let's talk about that
50 year? Or what
let's talk about that part, and then even the foam, why we test it every year. For sprinklers, about 5% of the sprinklers we have received to date have failed. And included in that, keep in mind, like, wow, that's quite a few. In that is O-rings, okay, which we still, even last year, it was about 4 or 5% of the sprinklers we received still had O-rings. Wow. Isn't that amazing? There's still a lot of those out there. And the failure rate on an O-ring sprinkler is anywhere from 50 to 70%. So the chances when you send me, if you send me 4, there's a pretty good chance one is going to fail at least, right? Probably 2 or maybe all of them.
Right.
So the chances of failure are very high. And remember, with this sprinkler test, if you send me that sampling of 4 or 1%, and even just one of them fails, now I got to replace everything that represented. Right. Right. But to your point, yes, quick response is not at, like dry sprinklers we tested at 10 because it had a high failure rate. Quick response is not at 20 or now 25 in the newest edition because it has a high failure rate. That is because it's a newer technology. Right. We don't have 50 years worth of data yet to say, we can wait till 50 years. But yeah, that is a very real possibility. I no longer with NFPA, and we can get into that too. You asked about NFPA Global Solutions. Part of this family, I no longer can participate in these committees. But if the committee so chooses going forward, they may want to push that back. Hey, the failure rates are good. So Josh, you had asked the question about, okay, do you use this data for anything? That is primarily where it is used. Yes, the committee is making decisions on how often do we need to test this.
And a little PSA for the 2026 edition, that's sitting on the committee, there hasn't been any drastic intervals that are proposed to change. So for those listening that are like, oh, do we get to 40 years on our drive? I'm sorry, no. But it's standard to the 2023 edition. Those intervals have stayed.
It's tough, right? Because we do want to make them all the same interval or close. Let's get 2 intervals. Yeah. Let's make it easier on people. That's a theme here today. Let's make it easier on people. But to get there means we're going to have to change in the additions. And now all of a sudden, not only do we have all these intervals, now every addition has different intervals. So it's a bit of a catch.
It does make me feel better, though, that there is data behind it, right? I mean, some of the new stuff, like with the quick response sprinklers, we had to pick a frequency, right? And it's okay, let's pick a frequency, throw it in there, see how we do, and then we'll adjust based on testing. But it is good to know that that testing data, not only is it required for the standard, but then we're accumulating all that data, right? And it's helping us make better decisions going forward. So I'm happy to hear
like
that.
Any NFPA standard, somebody has to make a comment and recommend a change, and anybody can do that. It doesn't have to be somebody on the committee.
It could be listeners.
But that would at least bring up the discussion amongst the committee, and then a decision would be made. They'd probably request data from the companies who do sprinkler testing and see where they're at.
I do think there's a major error in that, though, is you get rid of the sprinklers before 1920. And there should be a note in there. It's like, send one to Joan, send one to Josh, right? Don't dispose of those.
I'm getting a sense, are you a collector?
I can be.
Okay.
Right? I mean, and eBay likes them too.
Yeah. We've got
a
case.
I'm sure y'all have a pretty cool collection. Actually.
Yeah. Ours we like to call, though, we don't necessarily collect because they're old or rare. We collect the ones that fail. We call it our wall of shame. Yeah. Because everyone seems to be interested when they come to the office, like, whoa, look at that one, right? Like I got a hornet's nest sitting on top of deflector or just corroded to bits, right? And the wall of shame, because again, they should have done the floor level inspection, taken it down. But now I know that, okay, contractors know. It's the building owner who, no, still send it in. Let me see what happens.
So the goal is to not be on Dyne's wall of shame.
But the building owners should know, too, that if they go ahead and send that in, it's going to cost them more money. They could have just replaced it, right? And gone on. But because they send it in and it failed, they now have to replace all the heads. So it's a gamble, and I would say, go ahead and replace those ones that look like they should be replaced before you even do your testing.
So as we're talking about picking samples, when you send your box out, to send the sample back in, do you provide some guidance that kind of helps with that selection criteria? I know 25 gives us some guidance on it has to be a representative sample. You can kind of pick and choose, and that's a question that we get all the time is, okay, what is a representative sample, right? So I want to pick all of the same environmental conditions, same manufacturer. Orientation doesn't really matter so much, correct? But otherwise, all of the characteristics of the sprinkler should be the same, as well as
I guess what's an ideal sample for you?
Yeah, so let's talk about that. You mentioned, let's start there. You said, well, the orientation doesn't matter. That is correct. That's in the document. And now maybe we know why. We talked briefly about the test before. I don't check the water distribution pattern. So a sprinkler that's pendant or upright, to me in this test, it's going to be the same, right? The deflector part doesn't matter. It's still important. You still should do the floor level inspection. That deflector's bent or you have a bunch of loading in one half of the teeth there. Right now, I'm not going to get the water where I want it. So it's still a very important, just for the test that I'm doing. Yeah, the deflector doesn't matter. But if it's different material, if I have stainless steel versus brass or something, if it's a different mechanism, if it's release or water seal, all of that does matter, a different manufacturer, because it may have reacted differently in the environment. So you've done your floor level inspection. Now comes the time the building owner chose, I am going to test instead of replace. Now you have to take 4 or 1% of your sample area, whichever is greater. Right. So let's start first with sample area. That's not defined in the standard, and that's on purpose. They want a conversation. Really, it's up to the building owner, and usually the contractor will initiate that. Well, how do you want me to break this up? Let's say we have a conditioned office space and an unconditioned warehouse. And that's just in my example. Assume the one in the warehouse has failed. Maybe it's in an environment that's very humid, a lot more moisture, corroded. If I were to treat my building with the unconditioned parking garage or warehouse in my office as one sample, and I have that failure in the warehouse, now all of a sudden I got to replace everything, right, including the office. But if I were to separate out by environments where, okay, I have a conditioned office and then my unconditioned space, now when that one fails, now I just have to replace that one. So it is highly recommended to separate by environment, but it's not up to me. It is really up to the building owner. Same thing with high-rise buildings. We'll have some like, okay, I'm just going to take 1%, 4 or 1% from randomly from floors. And I'll mention when I say randomly, it shouldn't be the easiest to get to. It shouldn't be the ones that look the best because you don't want to look bad. You sold them it. Or it shouldn't be the ones that look the worst because you want to sell them the new ones, right? It should truly be at random. Just 4 random ones. Get them in there. And
Google has a random generator. If you really want to make it randomized,
there you go.
Number them and pick those ones.
You take those down, you get it to Dyne and get them tested. Now, a common question with that is, okay, what if I have more than 4? Let's say I have to send in 4. I got a building with 300 or 400 sprinklers, and that's 4. I got to send in 4. What if I have more? What if I have 5 types in there? You'll notice in the standard it says that a minimum of 4 or 1%. And you need to get each type that's in that area represented in your sample. So if you have 5 different types, maybe you have, for some reason, 5 different manufacturers, right? You're going to need at least to send in 5. That always says minimum of 4 or 1%. Right. So we're going to get at least 1 in there. And a lot of people, especially if you're into statistics and stuff, like 1, that's not really statistically relevant. But that is how it's defined. That's again, remember these standards are the minimum you got to do. So there could be an instance, we get that question all the time. Well, Grant, what if I have 5 different types? Okay, you're going to have to send in 5. It's a minimum of 4 or 1%.
Right, 4 or 1% of each of those 5, correct? Because the manufacturers could vary between, okay, the manufacturer A and B have the same characteristics, but one could.
To my understanding, and you could always submit a technical, if you send in just 1 of each and make up your sample of 5 and that one fails, you don't have to replace them all. Right. If you were to send in, which you could choose to separate. Again, it doesn't say. If you send in 4 of each, now if just when that one fails, now you have gotten to the point where, okay, now if that fails, I have a sample set of just those 4 I have to replace. If that one fails, I have to replace that type. Right. Does that make sense? So if you don't send in 4 of each type, then if one fails, you got all of those. That's your sample set. Okay. But I agree with you. Yeah, 1 is not a great sample set. I would highly recommend, and that could save you in the long run. Let's say there is one type that was more susceptible to some issue. Yeah, separate that out into its own sample set, 4 or 1%, send that off. And again, if that one fails in there, now you just have to replace that sample set.
Right.
So this is how you can use you have to pay a little bit more in testing up front, but it could prevent you from having to replace everything if you separate these out.
Right. Okay.
You're doing an RTI test with your sprinklers, kind of it's like a failure to launch, right? That's your fail point. Like it doesn't release or doesn't operate.
Yep.
On the foam side, what are we looking for?
Well, what the standard says, again, it's in NFPA 25 now. It was previously in 11 and they moved it to 25. But it is recommended that you test your foam annually. They kind of leave it up to the customer to determine, if you have 55-gallon buckets, you don't have to send in 50 samples. If they're all the same lot, purchased at the same time, stored in the same conditions, you can probably sample one of those and send it in. If it's in a tank, though, oftentimes it's a good time, or it's a good thing to sample each tank because, if it's a bladder tank, there can be a water leak. A lot of things can go south on foam, and I don't know. I guess foam is about 10% as well.
Correct.
For our failure.
Yeah.
But it's typically, like I say, tested every year.
But being more of a chemical-based test, like a chemistry-based test, are there a lot of concerns with their sample testing and contamination, or?
Well, you mean when you're taking the sample?
Taking the sample and getting it to you to do our testing, breakdown testing, whatever the case might be.
Again, we have sample jars, so what we recommend is they take a representative sample. So it's really up to the customer to determine how to do that. Our recommendation is you don't just open your pipe and drain out what was in the piping, because sometimes metal ions can negatively affect foam.
Right.
There can be some chemical reactions going on because of those metal ions. So drain out what's in the piping and then get to foam that's actually in the tank. We do specify whether it's taken from the top, bottom, or middle of the tank. Some customers will send in 3. If they've got a 500-gallon tank, it's a lot of foam, or even 5,000. There's big foam tanks out there. They'll sample it in different locations. In a bladder tank, too, it's really good to sample that top sample because that's typically where the water will end up. And water can be detrimental from a dilution standpoint, but it also can be detrimental just from messing with the viscosity. Especially a lot of the new fluorine-free foams tend to be fairly thick. They've added polymer to them to increase the drain time because they don't have film formation anymore. And some of them are not what we call fully hydrated. So if you add a little bit of water, the viscosity will actually go through the roof on some of them, not all of these. The manufacturers are really working and they're coming out with some good replacements, but it's going to take a little time too. With AFFF's, foam would last, like when I was at 3M, we'd warranty it, for 20 years. I mean, that's a long time for a chemical sitting in a tank.
If stored correctly.
If stored correctly, and
that's a good caveat to have in there.
And if tested annually.
Yeah.
That was also another caveat, that you had to have it tested annually. But there's a reason they call it forever chemical. That fluorinated chemical did not break down, and it lasted a long time, and that's what allowed the foam to work so well. So it makes sense that they would last. I think word is still out on some of the new foams on the shelf life.
Right. Do you shake your head when someone sends you a protein foam sample?
Well, no, you plug your nose. I still remember being in my 20s when your nose was very perceptive and having to test those before breakfast.
Like, which customer can we blackball for sending this 53 cent? No, I'm just kidding.
But we still get protein samples, I would say more so for marine applications that are in foreign ports.
It's the original fluorine-free foam.
Yeah. Yeah. Well, and a lot of them are fluoroprotein as well.
Yeah.
I find it interesting that when AFFFs went away, they didn't go back to straight protein. They're using synthetic surfactants as opposed to more natural protein-based surfactants. I don't know if it's just because of the smell or...
Our employees are glad they did.
Yeah.
Well, I'm sure that's both. You got the environmental concern and then probably on the other side, right, your animal...
Well, it might be an outlet for some of that, and certainly it's biodegradable. So that's a good part of protein foam.
Right.
So, yeah.
Because we brought up the failure rate, can you speak just a little bit about why foam fails? Like why are we getting these that fail?
Well, it can be dilution.
Looking at my notes.
Well, I brought it up. I just wanted to.
Yeah, it can be dilution. It can be storage conditions. If there's a lot of fluctuations in temperature, that can be an issue. The other thing that happens very often is you have a tank. You're going to test proportioning in the field sometimes, so you're going to use up some, and then you got to replace it.
Right.
They don't recommend that foams be mixed from different manufacturers, even different brands, but it happens. And so mixing two different types of foams together can cause an issue. The example we use is an alcohol-resistant foam and a freeze-protected AFFF. The ethylene glycol and the freeze-protected AFFF causes the polymer to drop out of solution on an alcohol-resistant foam, and that can just really cause a mess because now all of a sudden you've got this polymer. I don't know, the Texans call it calf slobber.
Okay.
That's what it looks like. And it does not proportion. There can be problems with materials of construction. You know, I mentioned metal piping, dissimilar metals where you get an electrical conduit set up and it changes. There can be problems with pH. pH is a very good thing to indicate that there's a breakdown in foam. You're either getting acidic analogs or basic analogs, and that's a breakdown in foam. We measure expansion. Sometimes we've had foams that simply don't expand anymore, and I think that's going to be the key with the fluorine-free foams, because expansion is what is allowing them to work. Mm-hmm. We're requiring them to have a higher expansion than an AFFF because we don't have that film formation, and these hydrocarbon surfactants just don't have the shelf life. They're not forever chemicals, and they are going to break down over time.
So is the antifreeze testing done at the same place in the lab that your foam is? Is it?
Yeah, it's another chemical test. Okay. Yeah. There is as you guys may be aware, right, the whole listed antifreeze and the sunset date of September 30th, 2022. And
I think we're well past now. I think that actually dropped out of the
when I started feeling old is once
and now, correct me if I'm wrong, but I believe in the newest 26 edition, you are allowed, it can remain in there, but as soon as you drain it out, you have to use listed product. Is that correct?
As long as you're meeting the testing criteria. So as long as you're still meeting your freeze point, which I think the idea behind it is we're supposed to be testing the concentration every year.
Yep.
As you take that test, we're going to bring in more water. It's going to eventually dilute down. So
that's the one that
I think that's eventually
like that. It's like if you're truly doing proper testing, I'm not sure how you. Just a personal thought.
Yeah. Well, that or you started with a significantly higher concentration. You were well beyond your maximum level concentration, anyways. But I think we're going to see less of that. I expect this is one of the things that I tell the people that come through our ITM classes is keep an eye on that section. I think that section is going to change a lot over the next handful of cycles, just as we start to transition away from those more traditional mixed in the field type solutions and into these factory listed premix solutions. But my other question is from the testing side, what are y'all seeing with the testing of the new stuff versus the old stuff, and kind of what is that looking like as far as longevity and breakdown and all that goes?
Yeah, I mean, it is so new, so it's hard, but so far so good, at least for the listed products. It originally was started with, you asked about it, same laboratory. For the most part, we test, like you said, the concentration of it. We give the refractive and density. If you look at data sheets, that's typically what they give you to compare against. We do have another room, though, with more sensitive equipment. The whole listed thing I brought up because we are able to distinguish if it's listed or not. Luckily, these listed products contain some additives. Some are patented, and you can go and look them up. Some are trade secrets. But it contains some of these additives that were never in legacy products. So I can, as a laboratory with my sensitive equipment, go and look for these additives, make sure at the right concentration, I can't tell you what's in there and at what concentration because of the trade secrets, but I can give you a thumbs up, thumbs down, like, hey, I think I have X. I have this listed product. I can say, yes, you do, or no, you don't. So we are able to distinguish for those that need that as well. Now, as far as what we're seeing, keep in mind with antifreeze, that's not required to be done by a laboratory.
Right.
So typically the results we get skewed. We will typically receive the failures if our antifreeze failure rate's relatively high, because typically the ones that have good records, the contractor knows what they're doing or it looks good. Right. They're just going to do it and be done. We're never going to see that. When they run into something like, I don't know what this is, I'm getting a crazy number, I'm going to send it to Dyne. So ours are skewed more to that result of the failure, because we do get the more challenging samples in this regard.
Fairly easy to sample once you learn in the field.
Yes.
And test.
Well, they're only measuring the density, though, right? So you really have to know
gravity or refractive index. Right?
Yeah.
Either or in most cases.
But you really have to know what you have,
For
right?
Sure.
Because if you have a different chemical than you thought you had, you could get a false reading by assuming the refractive index or density.
And so you've seen a ramp up in the foam testing since that sunset date's disappeared?
Antifreeze testing? Yeah. Especially the listed part. So that's something we came near the sunset date. One, took a long time, right, to get listed products. And then for us to develop tests around, okay, how are we going to distinguish these? But yeah, we do have a way to do that. And yeah, there has been some ramp up in that.
Awesome. So kind of what I'm hearing is we can do a lot of the testing in the field, but if you run into the situation where we're missing signage, which unfortunately
never happens, right?
That would never happen. I mean, everybody always has all the signage they need.
Yeah, if you don't know what it is, you're going to need a laboratory. There's just no way. Like again, the equipment's very sensitive, very large, very expensive to truly distinguish. Do I have this product or not? If you know what product, to Joan's point, is, then you could go reference the data sheet, check your density. But if you don't know for sure it's that product, you're going to get a number, but you don't know what to compare it against.
Right, and that's where y'all can probably help out a fair bit, is when I don't know what I have and I'm trying to figure out, okay, I know I have to pull a sample.
Yep.
Normally I would test in the field, but I have no information about what's in here. Send it off to y'all, and y'all can tell me what I've got.
Or whatever it is.
And then probably also whether I'm good or not. And then I can make that note for future of like, okay, now I know what I have.
Yes.
Right, but that actually sounds like it would save a fair bit of
And I think even the standard, it says, reference like the signage, records, or chemical tests. And that's okay, we can come in and we can help identify it if it's missing, which never happens.
No.
Everyone always knows what they have, right?
So interesting question for you. It's not to pick on our contractors by any means, because I never tried to. But like, what are some of your frustrations with the samples that you do get from people? There's got to be some, right?
Yeah, I mean, the lack of information, just like the contractors.
That sigh, I think, tells a lot.
Yeah, but it may not necessarily be the contractor's fault, right? They probably have a lack of information. Yeah, because we want to be able to, compare it to what it needs to be compared to. And sometimes it is difficult to get that information. Again, with some of the tests, we're lucky enough, like antifreeze, I'm able to distinguish products. And even if you don't tell me, I can figure it out. Same thing with sprinklers. I can look at the sprinkler, but I have no way of knowing like what environment's it in. Is this in a dwelling unit? Is it harsh? Where I do rely on those contractors to really fill out that paperwork and get it to us.
Right.
Do you have any others in mind?
Well, again, with foam, some people just have no idea what they have. Yeah. So we're telling them what they have, and we're telling them what concentration to mix it at for it to work, which is a little scary because you would hope that they know that.
Yeah. The sign data is there or something.
So, yeah.
The other scary and frustrating, which again may not be the contractor's fault, is just getting the same sample year after year, and we've failed it year after year.
Yeah.
Like, it's scary, right? Like, we have failed this last year. It looks exactly the same this year, right? So I don't know if that is the building owner being like, okay, the contractor is, you got to replace this. You got to replace this.
Try it again.
Yeah, but try it again, right? Where it's just, I hate to see them, just like with sprinklers, where it's clearly this is going to fail. I hate to see them waste their money, right? I'm not here just to take your money. I'm here to help you.
Yeah.
And it's just when it gets in year after year, like, what? We should get this replaced for safety.
Right.
Another question we get all the time is like, okay, we know Dyne's there, but are there other labs? And UL, of course, but are there any certifications that your lab has? Right?
Yeah. It's a great question. Yeah. So we have ISO 17025. Okay. I don't know if we're getting really in the weeds with contractors. Maybe don't.
Go for it.
Okay. But that is a certification for, testing laboratories, calibration laboratories. That's kind of the standard for that. We have a 9001 certification as well. That's just a more general quality control.
So we're not sending it to Joan's garage.
No.
Not anymore.
Not anymore.
No. And what that ISO entails is, for instance, on every particular test, we make a many samples, and we have different technicians test all those samples, and they don't know what the other technician got. And we establish uncertainty, and, we do it right. So we also have a very good system because of our ISO of making sure we keep samples labeled correctly. We have a database on labels and stuff. So I think that's what the ISO buys you, is just all those behind the scene things to make sure you're doing it right.
Yeah. So the standard will, doesn't say test with Dyne. That's the comment if we get into NGS. When we were acquired, they said NFPA writes the code and now you got a lab that tests. You're going to force us to use Dyne. No, it's just any acceptable laboratory. And I no longer, like I said, can participate on the committee. I can't go in there and slam my fist and you got to use Dyne. The committee chooses that, but it won't, right? It's made up of all these public sectors, right? So what's an acceptable laboratory? In the annex, it talks about an approved or acceptable laboratory. It's not by NFPA, right? It's basically the AHJ that has to. When you send me a report or a sample, I give you back a report, and then you take that to your AHJ. Is the AHJ comfortable with Dyne? That's where that ISO certification can come in handy. Right. And that's where in the annex it references in the newest edition, doesn't require that 17025 accreditation, but it says, hey, this is a good example of something a lab should have to do this work. So that can help the AHJ determine that. We've also done work with various states if they need us to jump through any hoops. Okay, you want us to get this? Okay, we'll get this. Like the Coast Guard with the work we do, we are an approved laboratory for testing foam for the Coast Guard. Okay. So there are some specifics to your question. Yeah. We talk about these ISO. These are very general ones, but there are some specifics as well that we have we've run into where, okay, we've given a report. AHJ's got some hoops they want us to jump through. Okay, we'll jump through hoops.
Do you do water supply testing for the MIC? And you see that also through 25, right?
No, not currently. Okay. No. Yep.
Yeah.
Yep.
Just trying to figure out, because sometimes we get questions in that as well.
Oh, yeah.
So we're coming up on time, and it's been a great discussion. I feel like this is like a multiple podcast eventually over time. Yeah. Any last thoughts or anything?
Let's briefly just touch on NGS. NFPA Global Solutions, right? That may come up. So, again, we've been around 25 plus years, since 99. Oh, this is a while ago now, right? These acquisitions take a long time. We started the conversation with this group, this NFPA Global Solutions. So NFPA, the nonprofit, has been around 125 plus years. How are they going to be around the next 125 plus years with the changing landscape, right, of AI and copyright lawsuits and whatnot? So they want to make sure that's secured and has funding to continue these research and efforts into safety and whatnot. So they decided, okay, let's make this for-profit entity, the NFPA Global Solutions, that can do some things the nonprofit can't and can fund. So that we're for-profit entity, but all of the profit goes to fund the mission of NFPA. So I think that was announced March of last year. And then we were the first acquisition, I think right in June, right before the CNE last year we were announced.
Right.
So that's kind of how it came about, how we joined that team. We're excited about it. It's been some good exposure for us, and NFPA team has brought a lot of resources and like knowledge and just connections, networking. So it's been good to get our message out, and we share a very similar belief on, well, even though they're for profit, we always kind of think a negative to that, but they still have that same mission of NFPA of let's help people. Right. And that's why they were so drawn to us. One, we don't conflict with their, like NFPA, all the contractors, engineers, consultants. We're just here to help those people, their customers as well, right? And so we share the same message. Let's make it easy. Let's help people. So that is technically, that's our connection to NFPA Global Solutions. We brought it up in the beginning, and then we got so involved in the standard stuff that no, it's all good. But I thought some listeners there are many that still aren't aware of it. Like, what is this entity and why do they exist? And
well, I think that was a big question from a lot of people. And that's still one that's out there. So hopefully that kind of does help clear things up. And I mean,
some of the main concerns again of now isn't that a conflict of interest? You have a laboratory again. Joan was the chair of NFPA 11, had to give up that seat, right? So they are very conscious of that. NFPA, the nonprofit, still very much independent, right?
So CNE, will you both be at CNE?
Yeah,
next week after this post, it'll be next week, which we're moving into the future.
Joan is presenting.
I'm presenting on fluorine-free foams and the transition, and what to do, what to look for, how to approach the problem. So
Awesome. So you got a booth there, I'm sure.
Oh yeah.
People can
Yeah.
get you there.
Now, as part of NFPA Global Solutions, it's obviously a big deal. It's their show, NFPA show. Like,
Yeah.
we'll be there every year.
Awesome. I think it's the first time I'm missing
Oh, really?
a CNE. My son plays in band, and they're going on a tour of Europe
Oh, wow.
to
nice.
play.
What a
So
great
I'm like,
opportunity.
I love NFPA CNE,
Yeah.
but
Yeah.
I guess we'll make a
It'll be next year.
pass. Yeah, we'll
it'll be
figure it out
back.
next year.
Yeah, Josh will be missing. I'll be there.
Yeah.
It'll be great.
Oh, yeah.
Yeah, so you-
Nate and I will probably both be there, and
Yeah.
it'll be a good time. But yeah.
With the bow tie?
Oh yeah, absolutely.
What's
Absolutely.
do you know what it is? We need to get you like a, I don't know,
Oh, I haven't
sprinkler
decided.
testing bow tie.
That would be fun. I'd be so down for that. I got to find somebody who's willing to make it.
The wall of shame on a bow tie.
We've been talking about, is there any way we can get our sprinkler oven in there and do sprinkler oven
That'd be
tests
awesome.
right on the floor?
I would be so down for that. That would be so cool.
Yeah.
For some
I
reason,
know, right?
Fire marshals seem to be a little picky at these.
Yeah.
Like,
Yeah. But we always bring that
big
Dropmaster
machine.
product. We have that in
That
our
is
repertoire.
cool. That is the demonstration on that is super
Yeah,
neat.
it's very eye catching. If any listeners haven't seen that before, I mean, you'll notice it in our booth. Yeah, the Dropmaster, just again in the same vein of helping these contractors get this work done. When you got to pull a sprinkler, you got all this water that's going to come out, right? You drain the
very
system,
clean
but
water.
yeah, right.
Yeah.
The video, if you watch the product, I don't know if it's called a demo video or whatnot, but that's me pulling a sprinkler down, and you can see my face. That's a real reaction as the black water comes down my arm, down my backside,
Start
and then-
saturating all the clothing.
yeah. So the Dropmaster, you just connect to your main drain. So you drain your system like normal, connect it. It's just going to put your system under vacuum. So when you pull that sprinkler, instead of water coming out, air goes up, and that air going up takes the water with it. So no mess, no smell.
Oh, you mean I don't get to taste the water when I pull
No.
the sprinkler? Because every time the mouth
iron
also
supplement.
seems to be open. Yeah.
Yeah, right. So that is something that will be at CNE if you haven't seen it before. It's the only product we offer. As a laboratory, we're very conscious about our independence. We can't offer, we don't make sprinklers or foam because that would interfere with our independence to evaluate them.
Yeah.
So this is just a product that's just there to help you take the samples, make it more efficient, easier on those contractors.
Even when you think you've got the system drained, you've got water locked somewhere.
Yes. And all of a sudden it all
All of a
comes
sudden
in.
it's- yeah.
And sure enough, that's above somebody's desk with all this
It's
expensive
usually
stuff.
the CEO's office. Or,
Yes.
Yeah.
Yep, exactly.
So we'll wrap it up. Make sure you check out Dyne at CNE. Come stop by and see us, and make sure that you're excited to listen to the foam. Oh, well, I guess Eric is. I'm not going to be there to listen to your foam, but make sure we stop in and listen
they
to that.
record
Always
it?
good information.
Yeah,
I think
it's
they
probably
recorded. Yeah.
This will be recorded, then I'll have to listen to it for sure.
You can't
It's the
get out
one
of
thing
it.
you're going to stream from Europe.
From Europe, at the pub. But thank you all for coming out. We
Yeah,
look forward to
thanks
more
for having us.
conversations.
Yeah.
Thanks for having us.
Thank you.
This has been the K Factor Podcast. If you enjoyed the show, don't forget to like, subscribe, and share wherever you tune in to podcasts. Or head over to our website for more. Reach out to us anytime at technical@firesprinkler.org. Stay safe and always learn as we keep the fire protection conversation going.